money is in the account now. Okay, so I'll come out to the side here and do this. Okay, since there's not kind of enough room in the table itself. Okay, so we need, after a year is rolled around, what is our new balance? Because this money has been sitting in there earning interest. Okay, so remember, you can use a simple interest formula on it if you're just calculating the interest in a little bitty time frame. Okay, so remember, I need the account balance. So that was going to be this formula. Okay, you could also do I equals PRT. And then get the interest amount and then add it back to the initial amount. That works just as well. Okay, this was the second simple interest formula that you just plug everything in and you get the account balance, because that's what I'm looking for here. Okay, all right, so after 1 year, I'm going to have what I started with, which is the 468, 407, 35 times 1 plus the interest rate times the time. The time is 1 year. So I'm going to put in a 1 there. Okay. So now I'm just going to punch this into my calculator. Okay. Let's see. What do we get? We're going to get 468, 407, 35, open parentheses, 1 plus R times T. Okay. This is going to give us our ending balance. Okay. After 1 year. Okay. I'll go ahead and write down the whole thing. So it's going to be $499,790, and then we have to look at the cents here. Okay, you would round to the nearest cent. Okay, like you always do. Okay, so we've got 64 here. The number after is a 2. Okay, so this is going to be after 1 year. We have $499,790.64 in the account. Okay, so I'm going to write this number in the box. Okay, and then what happens here, okay, so just to recap, we started with our 1 lump sum. Okay, it spent a year, because we're doing everything yearly here, earning interest. Okay, so after 1 year from the deposit, okay, this is how much we have in the account. Now we can make our first deduction, which is $35,000. Okay, that would be paid out to the family. Okay, so then you have to figure out how much you have left, what's your ending balance after the first payment. So you would take what was in there, the beginning balance, subtract out the deduction to get the ending balance. Okay, so you're going to do $499,790, is that right? And 64 cents minus the $35,000. Okay, and that's going to give you your ending balance. So your ending balance is going to be $464,790.64. Okay, so that's what's left in the account after the first payment. Okay, and then this money sits in the account and it's going to earn interest. Okay, we just made a payment, so a whole nother year has to pass before we make the next payment. Okay, so when it comes time to make the second payment, we have to figure out how much is in the account. Well, this amount has been sitting in the account, so it has been earning interest for a year now. Okay, so how much is in the account now? Okay, well, again, apply your simple interest formula here if you want the account balance. Okay, so we've had $464,790.64 sitting in there. Okay, you've got to multiply that by 1 plus RT. Time is again 1 year because it's been sitting in there for 1 year. Okay, so we can go ahead and figure out this account balance. Okay, so let's figure it out. So let's type in our numbers. Oops. Make sure you can see that. All right, so times 1 plus R times T. Okay, so this will give you your account balance. All right, so $495,931. And if we round appropriately, it's going to be 29 cents because, or sorry, 61 cents because you're rounding to the nearest cent. Okay, so again, here you go. You've got a 2. You're going to stay the same. So it would be $495,931.61. So that will go in this box. Okay, so this is saying when it's time to make payment 2, this is how much money is in the account. Okay, and then you make the second payment to the family. Okay, so $35,000 gets paid out. Okay, so then after the second payment, you want to calculate the ending balance after the second payment. So you're just going to take what you started with, subtract out the $35,000 payment to get the ending balance there. Okay, so let's go back and do this. Okay, so we've got $495,931.61. Subtract out the second payment of $35,000. Okay, so the ending balance there is going to be $460,931.61. Okay, and now this amount sits in the account. Okay, this is how much we were left with right after the second payment was made. Okay, so this money is going to sit in there for a year until it's time to make the third payment. Okay, so watch what happens. I mean, this is a very lengthy process if you map this out. So I'll do one more number to see how we got to here. Okay, but I had a spreadsheet. I put this in a spreadsheet and had it run it. Okay, just so you get an idea of where these numbers are coming from. That's why I'm doing the first 2 or 3 rows for you. Okay, so I'll go under here. So as far as going from this number to this number, okay, so remember after the second payment, this is how much was in the account. This money will sit in the account until it's time to make the third payment. All right, so let's figure out how much is in the account before the third payment, which should be this figure, but let's talk about where this came from. Okay, so you're going to apply your simple interest formula again. Okay, you've had $460,931.61 sitting in the account after the second payment, and it's going to sit there for a year and earn additional interest. So multiply that by 1 plus R times T. Okay, so let's do that. Okay, so go to your calculator. You're going to take this amount, multiply it by parentheses 1 plus R times T. T is 1 year. Okay, and that is going to give you this number. All right, so if we round it to the nearest cent, we've got 2 cents. There's a 7 after, so we need to bump it up to 3 cents. So when it's time to make the third payment, the account has $491,814.03. And that is exactly this number. Okay, and then you would take this number, pay out, make the third payment of $35,000. This is how much would be left if you did this minus this to get this. Okay, and then this money would sit in there for a year and earn interest. So you would have, that would bring you to this amount when it's time to make the fourth payment, and so on. Okay, so hopefully you get an idea of where these numbers are coming from. Okay, so if you just keep doing this process over and over and over until all the 35 payments are made. Okay, when it's time to make the 35th or the last payment, okay, this is how much is in the account. So just shy of $35,000. Okay, and then, you know, it's 6 cents short. Again, maybe rounding or whatever, but it is pretty much zero. Okay, you make the $35,000, you know, come up with the extra 6 cents, and then the parentheses here means that it's negative 0.06. So you can see that basically the account was zeroed out and covered exactly what you needed. Okay, so this was just kind of mapping this out so you get an idea of what our answer meant. Okay, this was our answer, the present value. Okay, it meant that if we invested this much, okay, this amount, okay, would pay out the annuity. Okay, because it's going to earn interest, and the amount of interest it's earning is covering the $35,000, and then what's remaining is still earning interest, and then you make another payment and so on, and the annuity gets paid out and it zeroes out your account. Okay, one thing I want to mention before we finish up this example. Okay, think about how much money John's wife and child received. Okay, so I'm going to write up here John's family. How much did they actually receive? They received $35,000 every year for 35 years. Okay, so if you multiply those numbers together, let's see here. They got 35,000 times 35. They got $1,225,000, okay, over the 35-year period, okay? But, wait, I lost my place. Yeah, so I just took $35,000 per year times 35 years. They got $1,225,000, okay? That is significantly more than this amount, okay? So the insurance, the insurance company didn't have to have $1,225,000 on hand to pay out this insurance policy. They had to invest a far smaller amount. This is way less than $1,225,000. They had to invest, less than $500,000 to pay out this total of $1,225,000 to the family. Okay. So that's what the present value of an annuity is. You're looking for this one lump sum that you would have to invest that would pay out an annuity over time. So I hope this helped you understand what this formula means and does. Okay, so let's do some more.